A very good morning to all of you. Once again, I welcome all of you in the today's practical. In the today's practical, we are going to perform one of the important practical, that is on hydraulic machine. So, in the previous practical, we was determine the efficiency for Pelton wheel turbine. So in the today's practical, we are going to determine the efficiency for pump. Okay. So we have two types of the pump, basically centrifugal pump and reciprocating pump. So how will you determine the efficiency? Then what is the purpose behind to determine the efficiency of a pump? Then why one should perform the efficiency for the centrifugal pump? That is the question in front of all of us. So whenever if you want to supply the water for irrigation purpose, okay, or even if you want to supply the water for domestic purpose, that is from the dam, then it is very necessary to supply the water by the pump. So pump is a device which is used to supply the water from lower elevation to the higher elevations. For example, we have a plumbing system in case of our residential building. Okay. So we have a municipal corporation pipe in front of our house. So with the municipal corporation pipe, we have to connect the our individual connection. Okay. And then we have to supply the water for the our roof tank, which is kept on the roof of the building, that is known as the syntax tank. And then from that syntax tank we have to supply the water for various fixtures, that is shower or wash basin, kitchen sink, bathtub, etc. So to supply the water from the municipal corporation pipe to the your syntax tank, which is kept over the roof of the building, in that case the pump is used. Even in case of the irrigation, if you want to supply the water for different crops in your field, then we have a pump setup. Okay, we have a pump setup. Then with the help of that we have to supply the water. So basically, if you want to supply the water from lower elevation to the higher elevation, in that case we require the pump. Now the another thing is that how will you define the pump? So pump is a hydraulic machine which convert the mechanical energy into uh, hydraulic energy. Okay. So it's vice versa for the turbines. So turbine is a hydraulic machine which convert hydraulic energy into mechanical energy and then electrical energy. But in case of the pump, okay, in case of the pump, if you see the definition, it is a hydraulic machine which convert mechanical energy into now hydraulic energy, then we called it as a pump. So the today's aim of the practical is determination of efficiency of centrifugal pump. Okay, that is the aim of the practical. So I am going to share the today's presentation with all of you, that is the determination of efficiency of a centrifugal pump. So I am going to share the content of the today's practical with all of you. Now screen is visible for all of you. Yes.
Yes, sir.
Okay. So this is the virtual lab. In the virtual lab, you will find that the various lab for the civil engineering, which is developed by the various IITs or NITs. So we have the virtual lab which is developed by NITK Suratkal. Okay. So under this fluid machinery lab, we have list of the experiment. If you see here, we have the centrifugal pump, then we have the Kaplan turbine, reciprocating pump, as well as Pelton turbine, then the Francis turbine. So these are the practical you can conduct or you can perform with the help of such virtual lab. So we are going to determine the efficiency of the centrifugal pump. Okay, so the aim of the practical is to determine the efficiency of a centrifugal pump, because we have to supply the water for irrigation purpose, or we have to supply the water for the roof tank which is kept over the building, and even in case of everywhere we require the pump to supply the water from lower elevation to the higher elevation. So we require the pump. So it is equally important that before bringing that, you can say the pump from the market. So we have to check the HP, horsepower of the pump, then the efficiency of the pump, and the discharge capacity of the pump, and then we have to uh, install the pump for irrigation or for supplying water for domestic purpose. So this is the basic things we should remember before purchasing the pump from the market itself. So now I would like to take some of the important theoretical aspect which is related to the centrifugal pump. So look at this particular, you can see the diagram. This is a practical lab layout diagram we have. So this is a sump tank, okay. Then we have a suction pipe. So below the center of the pump, this is the positions of the pump which is kept above the water level. Then from the center of the pump, below this center, the pipe which is called as the suction pipe. Okay, so this is a suction pipe. The suction, at the end of the suction pipe there is a footwall with a strainer. So what is the purpose of the footwall? It is a non-retaining wall, means it allow the flow in one direction only, the direction of flow along the motion of the fluid. When the pump will start, there is a arrangement, we called it as a footwall at the end of the suction pipe, and which is below the water level. So outside of this suction wall there is a strainer. It exclude the entry of whatever may be the floating matter which is present in the water. For example, we have a sand, leaf of the trees, any, you can say the soil particle or anything which exclude the entry after starting the pump. So that is the functions of the footwall and a strainer. Then here we have a pump setup. This is known as the centrifugal pump. In case of the centrifugal pump, if you see the component parts, basically there is a suction pipe, then inside this there is a impeller. Impeller is the rotating part, okay, which there are impeller, we called it as a rotating part. Then we have a casing, okay. So there are three major types of the casings: open casing, the different types of the casing. Then here we have a delivery pipe, okay, which deliver the required amount of water on the ground. And on the ground we have a tank again to store the water. Then it is equally important that we have to measure the height of water from the water level from the sump up to your ground level. So the water level from the sump up to the center of pipe, we called it as a suction head, and from the center up to the ground level we called it as a delivery head. So this is HS and this is HD. So HS means suction head and HD means delivery head. So HS plus HD we will get total head. Now if you want to calculate the total head, so the total head means the height of water from the sump level up to the your ground, then we call it as a total head. Now depending upon this head, the efficiency of the pump will depends, okay. Then we have a impeller. Look at this particular diagram. So this is the inside mechanism of the impeller. The impeller is rotating in this direction. Now what is the a basic principle of the working of the centrifugal pump? Through this you can see the suction pipe. The suction will create inside the suction pipe. Then there will be a centrifugal force which is generating in this inside mechanism, which we called it as a impeller. And due to that centrifugal action, there will be a possibility of creating the suction pressure inside the suction pipe, and there will be a discharge in the delivery pipe at the required level on the ground. So this is a simple, you can see the working principle behind this centrifugal pump, okay. And then we have a velocity triangle at inlet and outlet of the impeller. So this is a outlet velocity triangle. We have a V, then there this is inclined with the horizontal, so it has two component parts along the x direction and along y directions. So such kind of velocity triangle we also already studied. Then look at the different types of the impeller: open impeller, semi open impeller and closed impeller. So in case of the semi open impeller, there is a ring which is provided on the periphery of the impeller. Impeller is the rotating part which rotate with the centrifugal action with the fluid. And closed empirical means such kind of the impeller which is inside the a cage, okay, then we called it as a closed impeller. Now we have to find out the efficiency. So how will you find out the efficiency? Eta. So efficiency, which is equal to input power divided by output power into 100. So we have to find out the input power and output power, and then we have to determine the efficiency, that is output by input power into 100. So how will you determine the efficiency? We have these two formulae, okay. So how will you take the reading? With the help of the practical, we will going to discuss in the procedure. So I am going to start the step by step procedure for the centrifugal pump to determine the efficiency of the centrifugal pump. Now, to determine the efficiency for the centrifugal pump, we require this assembly or the lab layout. So this is a practical lab layout for the centrifugal pump. This is a suction pipe. Then to measure the suction pressure, we have a suction pressure gauge. Then we have the pump setup. We have the impeller. Then we have a delivery pipe. This is a delivery pipe, okay, which deliver the required amount of water at the ground level. And then we have a delivery pressure gauge to measure the delivery pressure. Then we require the tachometer. So we require the tachometer. What is the tachometer or what is its use? For example, if you want to measure the speed of the pump, okay, in RPM, revolution per minute. So with the help of tachometer, we can measure the speed of the pump. How will you measure? That is the main, you can say the questions, how to measure the speed of the pump with the help of tachometer. So basically tachometer is a device by which we can measure the speed of the pump. But how will you measure the speed? That is the question. Okay. So as far as concerned with our mobile torch, okay, when the mobile torch will start, there will be a rays which is coming out through the mobile torch, and if you impact that rays over a certain object, there will be a reflection, okay. So in similar fashion, the tachometer is the similar kind of the torch, okay. In case of the tachometer, there will be a rays which is coming out through a torch, okay, but the rays is like as a single rays and it is coming out. And what we have to do, there is a axle for the centrifugal pump, okay, axle is the shaft. What we have to do, we have to impact the rays which is coming out through the tachometer or the shaft of the pump, and on the tachometer there is a dial gauge, okay. So when you impact that rays over the axle or the shaft of the you can say the pump, when the pump will run, when the pump will start, what we have to do, we have to impact the rays over the shaft of the pump, and ultimately that tachometer will record the speed of the pump in RPM, revolution per minute. So this is a simple device by which we can measure the speed of the pump. Then we require the V notch setup. So here V notch, or we called it as a venturimeter to measure the discharge, okay. Then we have a hook gauge to measure the water level, and then we have a measuring scale. So such kind of assembly we required in case of this practical, okay. Now in case of the step number 1, start the pump by pressing this green button. What will be happening? The pump will start. The water is coming from the suction pipe into the impeller. Impeller will rotate. There will be a generation of centrifugal force. Now here, after starting the pump, what we have to note, which reading we have to note down? That is the suction pressure with the help of suction pressure gauge in kg per centimeter square. And then the water is coming in the delivery pipe. Again, the second reading we have to note down, that is the delivery pressure gauge. So we have a delivery pressure gauge here, and with the help of this, you have to note down the delivery pressure reading. So these two reading we required. Then with the help of tachometer, we have to take the speed of the pump, and as well as we have to note down the how much electricity will consume by the pump with the help of this meter. So this meter, electric meter, will gives us how much watt this pump will consume. Okay, so this is the things we have to note down. Then uh, what we have to do, we have to increase the discharge. So to increase the discharge or to make a constant speed for a centrifugal pump, so we have a wall. This is a wall, or we can say the handle. With the help of this, we can make a constant speed for the pump. So by using this handle, okay, we are going to set the speed of the pump. After setting the constant speed for the pump, with the help of tachometer, we have to record the speed in RPM. So the speed of the motor with the help of this tachometer. So what we have to do, this is the shaft, this point, look at this point. What we have to do, when the rays is coming out through this tachometer, what we have to do, we have to exactly impact these rays over this shaft when the shaft will run, and we have to record this is a speed of the pump which is in RPM. Then what exactly we can see in this diagram, see here, this is the tachometer. These arrows, these red arrows will indicate that how we can measure the speed with the help of tachometer. Okay, so there are two types of the tachometer, one is digital and one is the you can say the digital tachometer, and one is our traditional tachometer. So this is a traditional means we have a rod at the end of this tachometer. We have to uh, contact this end of this particular rod over the shaft point, and we have a measuring dial here. It will measure the speed in RPM. So how we can measure the speed? Basically nowadays there is a modification in the traditional tachometer. The traditional tachometer is replaced by the modern tachometer, that is the digital tachometer. So in case of the digital tachometer, what we have to do, we have to impact the rays on the shaft, and we have to measure the speed of the pump in RPM. Okay, then see here, this is the we have measured the speed of the pump. Then in case of the third step, open the delivery valve and allow the water to flow through in the channel. This is a channel. Take the hook gauge reading at the V notch. So when the water is flowing through this channel, this is the and the this is at the end of this we have a notch in the form of the, you can say, triangular notch which is fixed at the end of this channel. So what we have to do, we have to take the reading before and after opening the valve to find the discharge. Okay, so with the help of this notch we can measure the discharge. Okay, now initial reading, water level till crest. So we have a notch. So what we have to do, we have to take the initial reading, then we have to take final reading as we have seen in the notches and weir, and then head of water. Now after this, what we have to do, again open the delivery valve and allow the water to flow in the channel. Take the hook gauge reading at V notch before and after valve opening and to find the discharge. Okay, then we have to take the initial reading, then we have to calculate final reading and head of water. Okay, Then we have a formula to find out the actual discharge with the help of V notch. 8 by 15 CD tan theta by 2 under root 2g h raised to 5 by 2. So this is the h we have taken. This is the first trial result. This is the final reading. Then we have head of water and actual discharge. We can calculate. Then note down the delivery as well as the suction pressure gauge reading. So here we have to record suction as well as delivery pressure gauge reading in kg per centimeter square. Then we have to note down HS plus HD, that is suction head plus delivery head. We will get the total head. And then we have to record the suction head and suction pressure gauge reading. And we have to calculate the total head. So how will you calculate total head? HS plus HD. So HS is now 4.8 and HD is 1 meter. So 4.8 plus 1. So that is the total head. Okay. Then note down the watt or consumption in by the pump. So we have a watt meter. So reading corresponding to the discharge. Okay. And then we require certain observation. Watt meter reading WR. Then we have calculated actual discharge, then total head, and then the result. We have to calculate input power, output power, and the efficiency. That is output power divided by input power into 100, you will be get the efficiency. So this is how we can develop the practical procedure for the to determine the efficiency of the pump. And then we have to sketch a graph between the actual discharge input power, between the efficiency with respect to the actual discharge, then input power versus actual discharge, output power versus actual discharge, total head versus actual discharge. अभी बंद कर दो. ओके. हाँ गायधन है सर, बोलो ना. हाँ हाँ बोलो ना. हेलो, क्या बोले? हाँ, one notice for all of you. There is a parents meeting. So I request each and every student, request your parents to be present for the parent teacher meeting. Okay. फरजाद
Yes,
ज्वाइन होने वाले हैं ना?
yes, sir.
हाँ, नूरुद्दीन सैयद.
Yes, sir.
ओके. पल्लवी.
Yes, sir.
पेरेंट्स जॉईन होणार आहे ना मीटिंगला?
Yes, sir.
ओके. तेजस्वनी.
Yes,
तेजस्विनी.
sir.
ओके.
Yes, sir.
पेरेंट्स जॉईन होणार आहे ना तुमचे? हॅलो,
Yes,
पेरेंट्स
sir.
मीटिंग. हाँ, अंश.
Yes, sir.
सगळ्यांना एक सूचना आहे की तुमच्या